The first International Congress of Chemists was held in September 1860 in Karlsruhe, Germany. At this Congress, Italian chemist Stanislaw Koenitzaro presented a method for accurately measuring the relative atomic masses of atoms. This made it possible for chemists to agree on standard values for atomic mass. When the Russian chemist Dmitry Mendeleev heard about the new atomic masses being discussed in Karlsruhe, he decided to include these values in a chemistry textbook he was currently writing. When he arranged the elements in order of increasing atomic mass, certain similarities in their chemical properties appeared at regular intervals. This repeating pattern is referred to as periodic. He created a table in which elements with similar properties were grouped together, a periodic table of the elements. His first periodic table was published in 1869. However, this procedure left many empty spaces in his periodic table. Noticing this, he predicted the existence and properties of the elements that would fill in 3 of the spaces. These elements, germanium, gallium, and scandium, were all discovered by 1886. Then, in 1911, Henry Moseley, a scientist who was working with Ernest Rutherford, examined the spectra of 38 different metals. He discovered through his analyzation that the elements fit into patterns better when they were arranged in increasing order of atomic number. Moseley's work led to the recognition that it was atomic number, not atomic mass, that was the basis for the organization of the periodic table. Today, Mendeleev's principle of chemical periodicity is correctly stated in what is known as the periodic law. The periodic law states that the physical and chemical properties of the elements are periodic functions of their atomic numbers. Since Mendeleev's time, many new elements have been either created or discovered. This has resulted in several changes to the periodic table. The periodic table is an arrangement of the elements in order of their atomic numbers so that elements with similar properties fall in the same column or group. The discovery of the noble gases was probably the most significant change in the periodic table. Due to the discovery of helium in 1868 and argon in 1894, English physicist Sir William Ramsay proposed a new group to be placed between groups 17 and 1 on the krypton and xenon were discovered 1898. The final noble gas, radon, was discovered in 1900. The next step in the development of the periodic table was completed in the early 1900s. It was during this time that the chemistry of the lanthanide series was understood. The lanthanides are the 14 elements with atomic numbers from 58 to 71. The main difficulty that came in the process of separation and identification of the lanthanide series was the fact that their chemical and physical properties are very similar. Another step in the development of the periodic table was the discovery of the actinides. The actinide series are the 14 elements with atomic numbers from 90 to 103. The actinides along with the lanthanides belong respectively to periods 6 and 7 of the periodic table. However, the lanthanides and actinides are often set below the main portion of the periodic table to save space.